Greetings and welcome to the latest installment of the Senturus Knowledge Series. Today we're excited to be presenting to you on the topic of 10 reasons why Snowflake is great for analytics. Our agenda today, we will do some quick introductions, then we'll give an overview of Snowflake and cover 10 reasons why Snowflake is purpose-built for analytics. We'll then do a brief overview of Senturus for those of you who may not be familiar with our organization and what we do, and then some free additional resources, and then we'll get into the Q&A, so please make sure you stick around at the end for that. By way of introductions, today I'm pleased to be joined by a couple of my esteemed colleagues, Bob Loney and Reeves Smith. Bob leads software development and BI architecture efforts here at Senturus, focusing on software and cloud architecture with Snowflake, Power BI, and Tableau. Before coming to Senturus, Bob was designing, building, and scaling BI software, reports, and dashboards for use by thousands of different restaurants. Reeves is a Microsoft certified master and Snowflake SnowPro advanced architect. He has more than 20 years of experience working on various development and data warehousing projects across a wide range of industries, including banking, DoD, energy, entertainment, insurance, manufacturing, oil and gas, pretty much every vertical out there. So we're pleased to be joined by those two today. My name is Mike Weinhauer. I am a director here at Senturus, and I host many of our webinar events. So before we get into the content, we always like to get a sense for our audience here, and we have a poll here for you today, as usual. We're just curious, what brought you here today? Why did this webinar pique your interest? And just select one of those if you don't mind. I want to keep up to date on new technologies. Our organization is evaluating data platforms. Our organization is evaluating Snowflake specifically, or our organization has recently purchased Snowflake. Or if it's not on the list there, then select other. All right, looks like we got just about everybody there. And yeah, it looks like most of you are just here to kind of keep up to date on new technologies, but it's a good, almost 20% of you guys that actually own Snowflake. So that's interesting. Great, thank you for sharing your insights with us. And with that, I'm going to hand the floor over to Bob and Reeves. The floor is yours.
Thanks, Mike. Appreciate the intro and welcome to the presentation, everyone. We're going to kick off, like the agenda stated, with a quick Snowflake overview. So just talk a little bit about what Snowflake is. So Snowflake is software as a service. So don't go into Snowflake thinking that Snowflake is, a platform where you're building VMs and things like that. It is a software as a service type product. The benefits of that is low administration. A lot of the heavy lifting behind the scenes gets done for you. And then you can quickly start trials. So like you can today go to Snowflake's website to start a free 30-day trial, start banging away and seeing how Snowflake works for your use cases. Snowflake also goes with consumption-based pricing. So it's not a straight monthly fee. So it's all about how much data you end up storing on the platform and what type of compute resources you use. And we're going to dive pretty deep into that as we go along. Snowflake, the service sits on top of one of the three major cloud providers there. So you have AWS, you have Azure, you have Google. The Snowflake platform, software platform looks the same regardless of which service it sits on top of, but there are some reasons you might want to be on a specific platform. And Reeves, do you want to touch on that just a second?
Sure. And the nice part about Snowflake is because it runs on all the three major cloud vendors, is if your organization's already made the choice to go with one of those cloud vendors, you do not need to move to a specific one. You can use Snowflake from within your cloud vendors. You have to check, there's a couple of different regions that are available. They're not available in every region in the specific cloud vendors, but you are able to use Snowflake within the cloud platform that you're already accustomed to. So if you're saving all your data off onto AWS S3 or into Azure Blob, you don't have to move that data across. You can use Snowflake within that environment and read from your already curated or your already the data that you already have available to you. So it's nice that they're not forcing you into that platform. And as a, probably not today's case, but down the road, if you decided that your company decided to move to a different cloud vendor, you could do an easy migration by starting up a Snowflake instance in that new cloud provider and then just replicating all the data across. So very convenient there. It keeps you from having to, having to pick specific ones. You can use the cloud vendor that you like from that standpoint.
And something you brought up the other day is it really can save on some of those data transfer fees too. So if you were locked into AWS here and your data was over on Azure, you might eat up a bunch of money. So something to keep in mind when you deploy where your storage is if possible. Lastly, and this is what the bulk of today's webinar is going to talk about, it's an analytics focused platform. It's really not a transactional database. So don't think of it in those terms. Think of it more from a data warehousing type standpoint. And we'll talk about why here shortly. So the core of Snowflake really looks like a database. A lot of the database terminology is very consistent. You have a database and you can make multiple databases. Your databases have schemas and tables have columns. You can create views, users and roles, things like that. And it's ANSI SQL compliant. Reeves, I believe you mentioned something about kind of maybe the origin of Snowflake, why kind of it wound up here.
Yeah, and the origin of Snowflake started as some guys that were out of Oracle that decided they wanted to do a platform a little bit differently. So it is a SQL database, unlike some of the larger, like the NoSQL databases or the Mongos and stuff like that. It is SQL compliant and it adheres to the same type of SQL functionality that you have in any platform. It just can scale to a very, very large amount to keep up with large data. I've used it in organizations where they had petabytes of data and it was not, and Snowflake was easily able to handle it. So it can scale to an extremely large amount of data.
Excellent. So let's touch on a couple of unique concepts, and we're just going to hit a couple highlights here because there's a lot, but a couple big things. The one thing that kind of really stood out to me and that I've heard a lot is this idea of Snowflake, the company or the product name, and how that so closely aligns with the Snowflake data model. And the explanation from Snowflake's own marketing materials is our founders just really love skiing and snowflakes are made in the cloud. So don't equate Snowflake, the product, meaning that you can only make Snowflake data models in Snowflake databases. That's the key takeaway there. And it's a cloud data platform, so calling it just like a cloud database is too simplistic. It does have, this idea of compute and storage and things like that that we'll continue to see in the webinar. Reeves, do you want to talk to procedures and kind of the unique approach Snowflake's taken here?
Well, I really like Snowflake. There's some things that are just things to think about, and that's why we outline them here in a unique concept. Right now, the stored procedures in Snowflake are only JavaScript stored procedures. So as you can see, the stored procedure to the left would be one that you would run in SQL, and it uses regular SQL. Writing stored procedures in Snowflake right now are things that you have to do in a little bit different mechanism, and you have to do it with JavaScript. And there's certain, it's not, JavaScript might not be the first language that a SQL person understands, but as you can see, once you get a templated kind of idea, you could write it that way. That is the one thing that is probably the most different with Snowflake with anything else, is the fact that you have to write them in JavaScript. They don't return data sets, so in that too, you can't call a stored procedure and have a data set return. So those are the two little items that if you are a SQL person, you might go, oh, I just want that to be called out early and make you aware of that so that you're not trying to go down that path with that understanding. It is slated on the roadmap to write SQL stored procedures, and that's on the roadmap as of here. I would imagine at some point they will get to that, but that's just something to call out. that's a little different than your other SQL systems.
Definitely unique. Kind of the last set of unique concepts we're going to touch on here is this idea of truly decoupled compute and storage. And this idea is that you can have these warehouses, which are your compute resources that act on storage, and they can act on it concurrently. And again, the marketing is backed up by the technology, but the marketing phrase is virtually unlimited number of concurrent workloads against the same single copy of your data. Do you want to touch on, without getting too deep into the weeds, on kind of how they're doing that, Reeves? Because that's a fascinating concept.
Right. So their concept of compute is what they call a warehouse. So it's an okay term, but so when they say warehouse, they basically mean compute. And the nice part about the way that Snowflake has been set up is the storage they're using cloud storage, so they're able to have warehouses interact with that cloud storage and not interact with each other. So you can truly separate storage and compute to where you can have different loads. Like in this diagram, you can have the marketing people run with a different size of compute as compared to maybe the finance app, or as compared to the data transformation app is able to run at a lower level of compute, or a lower level of compute, which is what that means. They use t-shirt sizing, so they use large, medium, small, and it's the amount of nodes that are in that cluster of compute, and an extra small being 1, and they all scale up by 2. So an extra small being 1, a small is 2. So you're able to do separate workloads against that same data at the same time and not affect anyone else, which is really nice from a separation of storage and compute. And the last piece on that is the nice part with warehouses, because they're the thing that you get charged for. You get charged for compute and you get charged for storage. Well, the nice part is now, if anyone's ever tried to read a cloud bill, they're very difficult to read. But under Snowflake, it's pretty easy because it's storage and then it's compute. And so you could easily figure out how much the finance group had. And if you're billing back to groups, it's very easy to follow through with this concept of warehouses. So it's a nice little feature of how the service is built.
Well, we hope that kind of quick overview gives you some context as we dive into these 10 reasons that Snowflake is really built for analytics and analytics use cases here. So let's get going on that list of 10 reasons. I'm going to preview them here. So if you want to read through those real quick, we're going to hit these one by one and recap here at the end. So let's start talking about large data volumes. So again, you're backed by the cloud, so you can put as much data up there as you want, just about, because those cloud providers aren't going to run out of storage space anytime soon, and they'll just go buy pallets of more drives if they need them. They have this idea of flexible staging, where you can use stages from Amazon S3 directly, or Azure Blob, or Google Cloud Storage, any of those 3, and hook those into your Snowflake application, your Snowflake tenant. You can also use what's called an internal stage, which is part of the Snowflake application itself. So if you don't have those things set up, I know, Reeves, you mentioned maybe for like demo use cases, or
another use case could be is if I'm transitioning to the cloud, but I'm not ready to be in the cloud, meaning, or not ready, I shouldn't say that, excuse me. I'm transitioning to the cloud, but I haven't started that journey yet. And if you haven't started that journey, maybe I don't have things like blob storage or any of that kind of stuff set up, but I'd still like to try Snowflake out. If I use internal stages, is what you're basically saying is, Snowflake, you manage my blob storage for me, or my S3 storage. So it allows you to try Snowflake, and if you were in an organization that didn't have any cloud presence, I could try Snowflake and still have and use storage, but now you're letting Snowflake manage that storage. So that's
all that additional overhead. Absolutely.
Correct.
And that last point about fast data loading of large data sets, we're actually going to do a little example here. So Reeves, let me swap this over to you.
And then let me know that you can see my screen.
Looks good.
Okay. So this is the Snowflake UI, and this is what comes this is what you can interact with Snowflake, and it allows you to not have to have tools if you don't want. It's not to say that there's not plenty of tools that will that will allow you to interact with Snowflake. You can use tools like Data Grip or other tools that you're used to using, but Snowflake gives you this UI interface, and in that UI interface, I can look at the databases that are out here. I can look at the shares, and the shares are a concept where I'm able to data share and share different data sets. And there's a very unique feature, and we will talk about this later on in the meeting, about how you can share data and not have to export stuff through Excel, and you're allowed to share it and let people pay for compute, or you can actually pay for the compute. So it goes in both places. And the data marketplace is someplace where you can pull that stuff in. Again, warehouses is the compute concept, and I can make as many warehouses as I'd like, and I can set them up to whatever size we want. We, for this demo, just are going to be using the demo warehouse, which is an extra small. And in this instance of Snowflake, which is a standard edition, if I'm not mistaken, I think that's a $2 an hour spend.
Correct.
So if I were to turn on this database for an hour using this warehouse and using this warehouse for an hour, it would cost $2. You do see that it does, unlike some of the other providers, some of the other databases out there, like the Redshifts and the Snaps Analytics, it has an auto suspend feature that those do not have. And the nice part about that is, and you'll see as I run the script, I don't have a warehouse running, and I'll start doing stuff that needs a warehouse, and it will kick the warehouse up for me and start it. And then it auto suspends, and you can have auto suspend times. You can set whatever you want from that standpoint. You also have a worksheets tab, and this is where we will be doing most of the demo. And then a cool little feature is you can see when things are run, and now you're gonna see that you can see that when things are run, what kind of functionality. And if you're used to SQL Server, this is kind of that same idea as Profiler. And this is restricted by accounts. As you can see right now, I'm an account admin, so I can see everything here. But you can see that a warehouse had to kick up for this command and this command, but there was no warehouses associated with this. And then you have the account tab if you're account admin, and that's for roles and users and stuff like that. But so that's a quick view of the Snowflake UI. But in this demo, we want to really show, because everyone talks about, big data, right? So I want to create a table. And again, standard SQL. I create a table. As you can see, that the demo warehouse is not on. So these DDL type actions don't require a warehouse. So I can create tables and I can do stuff like that without having a warehouse. But the second I then need to do something that requires a warehouse, it will start up. So you should see that come up, and maybe that's just a UI thing. Or because I did this just a second ago, it had this already cached, and it's probably used that from a cache actually.
There you go.
So, and that's why the demo warehouse didn't start. And that's another topic of, they cache as much as they can to be able to show you, so that you don't have to rerun the queries and pay the compute cost. You can just get it from cache. So in this example, I'm going to pull in some taxi data, right? And we have this out in a stage, and it's an Azure blob, and we've created this concept of what we call a stage to point to this location. And what I'm doing here is I'm saying I want everything from this folder, and I want to use this pattern. And I'm saying, give me all the data, and right now I will be using all the files that are in that location. And as you can see, there's 15 files there, and they all kind of fit this trips data 2019, 1, 2, 3, 4, 5, 6, 7, or 1, 2, ABC for the different days. Or I think that's actually months, excuse me. So if I were to say I wanted to see the first data, so I can limit it, and I'm using this list command to just show you, because I'm going to do the exact same thing in a copy command. And so I can come through and I can do that exact same thing and copy all this data into this table, because you saw from this query there's nothing in there, right? So if I were to run this command, and that would start loading all the data from this location. But what didn't I do? I didn't limit it by a month, right? So I'm actually pulling all 15 of these files. And all 15 of these files are compressed CSVs, and they're about 60 megs. So there's actually a ton of data. So in normal demos, you wouldn't try to do these kind of feats, because you'd be right here. I just want to prove that this works. But I like to prove that this is a big data solution. And as you can see, I just loaded all 15 of those files. So then the next question you'd say, well, how many rows is that? Because it might not be that impressive, but because without commas, it's hard to see. If I were to put the commas in, you can see that's 37 million rows. And now you'd ask the question, well, okay, I can load 37 million, but that doesn't solve any problems if I can't query it very quickly. Just loaded that data. I now see 37 million rows, and I just ran a query over 37 million rows in less than a second, aggregating all the particular locations. So
And you're using the extra small warehouse
yes.
this entire time, aren't you? Wow.
Exactly. And if I were to actually do the calculation and this query, the load query, I can come back and look at history, actually was in 27.46 seconds. So if I wanted to actually do the calculation, because cloud's expensive, right? That would have cost 1.5 cents. So, and if you do it for real, because Snowflake bills you at a second after a minute. So if I were to start it and stop it, under 30 seconds, I still get billed for a minute, but after a minute, I start getting billed on a second. So that true cost was 3.3 cents to run that if I turned and suspended my warehouse. So I've worked at databases.
Really impressive performance.
I've worked at databases a lot. And if that's not something that you go, wow, that's pretty amazing, then I don't know what databases that you've been using. But yeah, that's that from that standpoint.
All right, I'm gonna take back over here, and we'll keep going. So that was point number one, large data volumes, and I think we kind of proved out that fast data loading for sure. Reason number two, data loading flexibility. So we just saw some file-based examples of how pulling in data into Snowflake can happen. There's a few other options. There's something called Snowpipe, which is kind of this API event-driven loading, where you can trigger off of events to have the load come in. Still, again, file-based somewhat, but that idea that you're not setting up a, hey, every day at 10 a.m. run this, which is can be a common ETL. It's more as data gets generated and written to S3, for example, events get triggered that then pulls the data right into Snowflake, and you're ready up to the minute, as they say. And then alternatively, you have wide tool support. So they have a lot of data integration partners. If you're using, let's say, Oracle as your data warehouse currently, and you're looking at going to Snowflake, and maybe you're using Alteryx as your approach to loading data into Oracle, well, you could just repoint that, it's ODBC or JDBC type drivers, and start loading Snowflake, and off you go. And so this kind of tries to summarize a few of the different ways that you can pull data, either from web applications through APIs into Snowflake, the external stage, like we just saw, this idea that you can also use a command line tool to copy it to Snowflake's own internal stage and then pull into the database, or the third-party tools also going into Snowflake there. So lots of different ways to get data into the system, which is always beneficial. Next, we're going to talk about broad BI tool support. So you'll see the three tools there with the Senturus logo that we are partner with those tools. We're going to do a quick demo on how the connection works, but on the right side, you can see from within Snowflake, you can download ODBC drivers, which those tools use, or JDBC drivers in the case of Cognos. There's other types of drivers and connectors and command line tools. Lots of flexibility here on how you talk to and connect to Snowflake. So let's real quick run through just that connection process in Tableau is where we're going to start. So you're going to connect to a server in Tableau, and if Snowflake's not here, you'd bump out your more, and you're going to give it this server URL. This comes from your Snowflake URL. So if we go back to our Snowflake environment, you'll see this root URL. That's what we're going to pull in there to the server, you tell it which role you want to connect as, you give it your username and password, and then we're going to log in. And since we need compute resources, we have to select a warehouse that we're going to use. So this compute warehouse was already running. So we're going to select that guy, and then we're going to just select one of our databases. This test database is extremely simple. One table, one schema. You pick your schema, so then your table, and you're connected. You can pull data. You would do your normal Tableau data visualizations just like you always would. Let's look at that same process real quick in Power BI. So in Power BI, you start with the get data, connect to use the Snowflake connector. We again need that server name. So let's grab that again. This is where Power BI isn't quite as nice. We don't get the nice drop down like we got in Tableau. So we actually have to know that our warehouse is called compute warehouse. Get a couple other optional columns. We don't really want to pull all the data in. In this example, it wouldn't matter, but typically to data sources like this, you'd want to direct query. It's going to prompt us for our Snowflake credentials. If you've done that before, it gets cached off locally on your machine. And at that point, you're doing the typical navigator experience of what database, what schema, and what table you want to use. And then from there, you would do your typical Power BI visualizations, which we're not going to get into today. And just to show, we're not actually going to walk through the Cognos example, but in Cognos, you would configure it just like any other data source, again, leveraging that JDBC driver that you'd install, referencing a warehouse, same concepts, just a little different approach from the tool standpoint. All right, let's go into reason 4, the support for analysis-ready data models. So modern BI tools like Power BI and Tableau and Cognos that we just saw, they still work really well with star and Snowflake schema data models, right? So you can use other data models, they support it, but when your business analysts really get in and use models, they're most effective and they work best when you can kind of present them in this analysis-ready view of the data. So Reeves, do you want to talk to kind of what you typically see folks do here on top of, their root, once they've pulled in that data, how this kind of plays out?
Yeah, I think the big thing here is the tool, unlike some of the big data tools, don't force you down any of the modeling that you can't already do within a normal database. So, or within your traditional databases. So you can model it however you want from a standpoint of, you can model it if you wanted to do a data vault, you can model it with, any kind of normal modeling that you've done for data warehouse loads. I mean, you do not want to use Snowflake for transactional loads. That's not what the system was designed for, and that's the one. But I could still build the model in that way if it was not loaded on a row by row type basis. And you'll understand as you do more things with Snowflake, it's just that's the use case that it's not ideal for. It's ideal for large amounts of data and queries like what I did in the demo. And one of the things that it didn't note in the demo, did you see me create an index? I didn't have to do any of that stuff. So you're able to model nicely like what we're talking about and then not have to do a lot of the stuff that we have to do in other systems. So.
And so, we sort of talked about the idea that sometimes you can use views, sometimes you can actually make another database and kind of use that database as your data mart. And there's different ways to create these analysis-ready views of your data. And then how do you want to implement security becomes a big thing too, right? So just a quick mocked up example here that we put together is maybe your ingest tables maybe don't come in as, the star schema, so you build some BI views on top of them, and then you have a user that's sort of restricted to that schema, so that regardless of who's using it and which warehouse they're going through, that user's only seeing the view levels instead of the data tables. But your data science team might come back and say, hey, we don't want the analysis ready views, right? Just let us have the data. So you could give them a different user with different permissions, or even a different database if that's how you wanted to play it out. Anything to add there, Reeves?
Sorry, I'm on mute. Oh, no, I'm not on mute. No. Oh, sorry. I thought I was on mute. No,
you're good.
Sorry. No, I didn't.
All right, we'll keep rolling here then.
Okay.
So you touched on this just a second ago, this idea of minimized administration. And this is from some of Snowflake's partner marketing materials here, this idea that like in a traditional database, you're doing all these admin tasks, right? On top of potentially hardware maintenance and things like that, backups and queries, query planning hints, partitioning, all this stuff that you got to worry about. And their approach is really just like, forget about all that. We're handling it under the covers. They will dive into some of the how they're handling it, but at the end of the day, the impression I get at least is this idea of don't even worry about what we're doing under the covers. Is that fair to say?
Oh, for sure. Yes.
Yeah.
And it's nice because they've taken that piece away to where you don't have to do the indexes, and in other large systems like Synapse and Redshift, you have to distribute the data because it's a MPP system that's not sharing storage. So a lot of that complexity is taken away. And
now, is that always to your benefit though? Because I know, like, we've talked about maybe query hints. I'm writing a query and I want to add an index and I want to use it.
The thing that they'll suggest, and the only thing that you can actually do, is you can actually sort data into the partitions. So in sorting the data into the partitions, you can do partition elimination, which is common in other databases. That's the best thing you can do. And it's something that we didn't see much of a benefit over, and we were working with tables that were 22 billion row tables that were loading every day. And we didn't see much of a benefit there. And even when we were joining those 22 billion row tables together, we didn't see that much of a benefit. I've run things where you're almost in the trillions of rows, and I didn't see that much of a benefit in specific queries. There might be edge cases that's the case, but is what I'm getting at is for your large data sets. And when I say large, I mean, I would doubt that many people would have trillions of rows. I mean, if you're talking IoT stuff, yes. But if you're talking normal stuff, you're probably never going to see that, and you don't really have to get to that level. So I would say you don't really have to do that.
Great points. All right, let's talk about some performance scalability. And we've kind of started to see glimpses of this as we looked at the Snowflake UI. But this idea that each of these different warehouses can have different sizes, they can start and stop when they need to. There's even some scale up, scale out, scale back down type features. So let's swap back to Snowflake UI real quick. Just highlight how simple a lot of this is. So whenever you have a suspended warehouse, if you're manually restarting it, and these things will automatically restart if some query comes in and tries to use them. But if I wanted to resume this manually, I actually get a pick at what size I'm going to resume this already created data warehouse at, right? And then they also tell you the credits, which again comes back to the cost side of things on how many credits, how much you're spending per hour when you use it. So really easy to scale up or scale down a existing warehouse. And then if you have some of the more advanced additions, you get this idea of clusters. So let's think about your typical analytics use case of everyone comes in on a Monday morning and runs all their reports, right? You don't want to always be running an extra large warehouse all week long for that use case. So you might run a small warehouse all week and then let that small scale out as it needs to. You know, how many clusters do you want it to go up to? How much does it come back down? Does it suspend or does it not suspend? All those types of things. So very flexible and just very, you know, from a UI standpoint, very streamlined and easy to understand and implement for the administrator.
Easy to manage, and
Yep.
a lot of self-management, which is pretty nice.
Absolutely. So real quick, we're going to talk about semi-structured data, and this is, you know, maybe an approach you'd see if you're doing a lot of big data manipulation, or I think Reeves, you mentioned the other day, maybe if you had some data coming in with schemas that change a lot, or maybe they're not always consistent. But there is wide support in Snowflake for XML, JSON, and other semi-structured data. There's this variant column concept where you can just pull that entire block of XML or JSON into a column. And then there is a file format concept where when you're pulling data in from a file, you have to tell it, you know, a little bit about the structure of that type of that file. So you're giving it a type. Is it JSON, XML, something else? What do you want to do with null values? Is there like an outer array, meaning like sometimes you'll get back like this results top level array around JSON data if you were hitting an API maybe. Maybe you don't want to pull that piece in because it's just repetitive and not useful, things like that. And then when you actually load the data, you can do it with the UI or through, you know, procedures or scripts. You're going to use that file format and reference that file to pull it in. And at that point, you can kind of build views or other queries to parse apart that XML or JSON semi-structured data. You can even type it, so you can see like it's being cast to a varchar, alias them, just anything else you want to do with that type of data. Very flexible for those data scenarios. Anything to add there, Reeves?
Yeah, and the nice part about it is you could use Snowflake as a you could call it a data lake for stuff that you are using possibly and that you want to use down the road, but you're not 100% sure, but you'd like it there to be able to query it without having to worry about using other features like Athena to query S3 and stuff like that. So it enables you to put that to pull that data in and then query those pieces off those tables. So it's you could think of it as a staging. You could stage all those
Yep.
documents.
And then the only table in Snowflake would just be a table that had a single variant column, correct?
Right.
Okay. Interesting.
Yeah, usually a variant and a timestamp of some sort, so you can see when stuff comes in.
So great support for semi-structured data in a variety of formats is the kind of summary bullet point here. These last few points here, we're going to get into some of the fun stuff that you can do with Snowflake, in my opinion. This cloning feature is really, really nifty. So on the right side, you see this little diagram of what they call zero copy technology. The idea is that if you copy a database, you're not actually copying any data. It's just kind of a metadata layer that sits on top of it. And then once you start modifying data in that new database, you're just storing off that slice of modified data information. So really powerful. The DevOps implications here are very powerful. You could, you know, copy your prod back to dev, no matter how big your prod is. And since you haven't actually replicated all that data, you did not cost yourself any more money. Just a very small slice of metadata information gets generated and copied at that point in time. And same thing for promoting tables. Sorry, go ahead, Reeves.
I was just going to say the nice idea is that most of the time we have problems when we're developers, right? We test it against a small subset of data. The nice part with the nice part with Snowflake is you no longer need to do that. I can clone the database. It's a metadata operation that basically now I have 2 pointers to the same amount of data. If I go to modify it, because it's production, everyone's like, oh, you can't modify production. If I go to modify it, there will be different partitions that are separate from the ones that the production data is pointing to, so you don't interfere, and you're only adding additional storage as you start to modify things. So it takes a deep dive into understanding what's going on underneath. But the simplified version of that is when I do a clone, there's no storage cost there. If I were to modify that clone, I modify it separate to what I cloned, so that is left alone. But the nice part to that is I can now run my test loads against a production scale, which is incredible. Yeah. Yep. And I can then delete that clone and nothing had affected what was in the production database.
Thanks. Perfect. Yeah, we're gonna run through a really quick view of demo of what that looks like. So we have this prod database over here. Doesn't have a ton of data, just a few tables in there. But we're gonna create a new database called dev cloning prod, and you're gonna see that this executes against my small warehouse very quickly for 5 seconds. If I refresh this over here now, you'll see that I have a new dev database. Great. I'm going to swap my context of this current worksheet here to dev, which also you can do using this drop down over here. So now that I'm in dev, let's go ahead and create this new table, my new table. Then I'm going to add to my database to do some development, and I'm going to put some test data in there. I'm going to go off and do whatever development I'm going to do. Let's make sure we have our test data in there. Great, 1 row of data. Perfect. I go do everything. Everyone signs off. I'm ready to promote to dev. So, or promote back to prod. So we're going to use prod and then use the same clone keyword here to create my new table in prod from dev.public.mynewTable. So it's now pulling up that table into prod, and in prod, let's go ahead and select star from that new table. There's my test data. I actually didn't mean to bring that up into prod, right? But the interesting thing here is that clone command did bring both the schema and the test data all the way into prod. So to fix that, let's drop that table, and then let's recreate that table in prod using the like command. So instead of the clone, we're doing a like, which is only going to pull up the schema. And then lastly, we'll select star from that in prod and see that we're back to not having any test data in prod. So really powerful ability to, clone your production back into a dev database and do testing or, investigate an error maybe. And then also if you're doing new development or fixing things, being able to promote tables and things like that into prod in a couple different ways. All right, time travel. You want to speak to this one, Reeves?
Sure. So with the way that Snowflake stores and stores data, it allows you, because I'm one thing to understand, just all this storage for Snowflake is non-updatable. So if I need to update something, I'm going to create a different partition with that data now in an updated fashion. Because of that, I can go back to what I previously had prior to that update or prior to that change. It has storage implications, so there's some storage implications if you were to do that, and hence why a transactional system wouldn't be great, because if you're updating a row by row, it's not a good idea. But because of the way that they store it in a data warehouse fashion, you're able to look at things previously that didn't. I mean, the great example is I drop a table and I can undrop. There's an undrop table in Snowflake, and who wouldn't love a database that has undrop? That right there, reason number one.
We've never made that mistake.
Exactly. But I know a friend that might have. So yeah, so you have things like that, and that's what time travel buys us. It's that ability to go back and look at specific things. Now, to keep this on an easy, this is an introduction. We're not trying to get too deep into the weeds, but the concept is I can make tables that store data for a specific period of time, from let's say 1 day to 90 days, depending on how I set the table up. So I could make updates if they happened every day. I could make updates, and with those updates, I could go back and look at what it looked like 10 days ago, 5 days ago. So it makes it very nice from that standpoint. So there are storage costs because you're keeping and you're paying for all the storage that you keep, but the benefits are nice. And that's why for some tables, you can create transient tables that don't keep much history, and then you can create your regular tables, but it allows you to not have to worry about doing backups and stuff. Excuse me, stuff like that.
Yep.
So, and
Beautiful.
I think somebody asked the question about cloning, and just to kind of go back to the cloning, when I'm cloning an object, I create a new object. So any connections to that existing object still remain connected to that original object. So it has no effect. The clone is now a new object.
Great point. So let's run through a really short, brief time travel demo just to show what it does here. But a simple table, 3 lines of data here, sitting here on a database. We're going to insert a 4th row of data, just like you normally would. We're going to select star again. You'll see we have 4 rows of data. Fantastic. But we can now ask the question, what was in this table 2 minutes ago? So select star using this at and offset, and you'll see we're back to only having our 3 rows of data. So there's this offset keyword. What are the other options that we can use there, Reeves?
You can use query ID and you can use specific time. So I can sit there and say, what happened prior to this query ID? And then I can also say what happened at midnight at 2 or midnight,
Gotcha.
Specific seconds. So those are the things that you can go back on.
Beautiful. So great, nifty, very helpful. And I think that last point is you don't have to worry as much. That's very powerful for all of us. A little less stress is good. And then lastly, point number 10, we're going to talk about data sharing. So 2 kind of use cases here. One is this idea that you can pull in curated data sets into your environment and then maybe add them to your enterprise data warehouse, or just do some ad hoc analysis, whatever you're wanting to do with those. And then the second one being you can share your own data with partners or have partners share their data with you. It's all safe, secure, streamlined connection. So let's take a look at what that looks like. So if I click on this data marketplace tab here, I'll go to the data exchange over in Snowflake. And so we're going to just do a quick search on COVID since that's popular these days. We'll see that lots of folks have published lots of different COVID data sets out here. State of California is interesting, so we're going to use that for this example. Tells you a little bit about it. We do this get data. We get to pick the database name that this is going to show up as. So CA COVID. So account admin is going to get this by default. Let's just go ahead and make it public in our environment. Should be sufficient. We're going to accept the terms. This is really key here. You want to talk to that, Reeves, real quick? Well, we finished making this. Data is not going to consume any storage space.
Right. So if I'm using a shared database, I'm basically now getting pointers to their database, and that's why I'm not incurring the storage costs. And in sharing, I can set it up in 1 of 2 ways. If I don't have Snowflake customers, they can use my compute, and I pay for the compute and whatever storage if I'm sharing it. In this instance, these people are sharing the data, so they're paying for the storage, and now we are using that data and would pay for any compute on that data.
Yeah,
that makes sense.
We're just going to do a quick query here against that database that's now obviously visible in our environment. So you can see how you can pull that in. Maybe you could populate another database with that. You could, there's all sorts of different use cases for how you might want to use this to then expose it either to your business analyst and other business users, or just do some ad hoc comparison right within Snowflake itself. All right, and so that really kind of concludes the 10 reasons that Snowflake is built for analytics. The recap of those, and again, you can definitely download the slide deck. We're going to do a Q&A here in a second. Once we get through a couple quick slides, the first being that if your organization is starting to use Snowflake, if you're thinking about using Snowflake, Senturus is here to help you. We can help with data warehouse migration projects, enhancing performance, just overall BI tool and data center architecture, things like that. We're offering kind of as part of this is a free hour consultation on your Snowflake environment. Just reach out at info@senturus.com or the number there, or feel free even to put a question in the question bar. We'll make sure to get back to you soon there. And Mike, I'm going to hand it back to you, run through these next couple slides.
Great, thanks, Bob. Yeah, stick around, everybody. Get your questions in the question pane. We do have some great questions in there. Reeves, maybe start taking a look through some of those. I know you've answered some of those in the question pane, but if we have a few minutes, it'd be great to maybe go over a couple of those. But for those of you who may not be familiar with Senturus, we are the authority in business intelligence. We concentrate and focus solely on business intelligence with a depth of knowledge across the entire BI stack. Our clients know us for providing clarity from the chaos of complex business requirements, myriad, disparate, ever-changing data sources, and constantly moving and changing regulatory environments and targets. We've made a name for ourselves because of our strength at bridging the gap between IT and business users. We deliver solutions that give you access to reliable, analysis-ready data across your organizations, enabling you to quickly and easily get answers at the point of impact in the form of the decisions made and the actions taken. Our consultants are leading experts in the field of analytics with years of pragmatic real-world expertise and experience advancing the state of the art. We're so confident in our team and our methodology that we back our projects with a 100% money-back guarantee that is unique in the industry. And we've been doing this for a long time, coming up on 2 decades here. We've been focused exclusively on BI for, again, nearly 20 years, working across the spectrum from Fortune 500 down to the mid-market. You probably recognize many of those logos on the screen in front of you, solving business problems across virtually every industry and many functional areas, including the Office of Finance, sales and marketing, manufacturing, operations, HR, and IT. We pride ourselves in the fact that our team is both large enough to meet all of your business analytics and project needs, yet small enough to provide personalized attention. As mentioned earlier in the webinar, we encourage you to visit Senturus.com and the Senturus-resources tab there, where there are hundreds of free resources on our website, from webinars to all things BI, including our fabulous up-to-the-minute, easily consumable blogs. Bookmark that. Thursdays are our typical time for these events, and we have another event coming up on November 19th. So next week, data integration options for Microsoft Power BI. That'll be one of our right tool for the job webinars. So head on over to Senturus.com and look at the events page where you can register for that. And of course, we'd be remiss if we didn't bring up our comprehensive BI training offerings. We offer training in the top 3 major BI platforms, Cognos Analytics, Power BI, and Tableau. And we're ideal for organizations that are running multiple platforms or those moving from one to another, as our trainers are conversant generally in all 3 of those platforms. We can provide training in many different modes, from tailored group sessions to mentoring to instructor-led online courses and e-learning, and we can mix and match those to suit your user community. Senturus provides hundreds of free resources on our website, and we've been committed to sharing our BI expertise for over a decade. And with that, that brings us to the Q&A. And Reeves, Bob, I don't know if you had a couple picked out there, though, but there were a couple of good ones in there. Or do you want me to pick one for you?
I can. There was a top 3 to 5 reasons to pick Snowflake over other database platforms, and the first one is Snowflake is easier to manage than almost any of the other platforms. There's no indexes, but performance is still really good. I do like the separation of storage and compute over the other platforms because I don't have to keep things running to answer queries. And the other piece that I forgot to add, and somebody else asked a question about it also, is can I do this at a small scale? And the answer to that question is yes. The nice part about Snowflake is I can start off, and it's because it's a consumption based, I can start off on a very small project and scale up as the project expands or as the data expands or as the need expands. But I won't incur those costs where in other providers and some of those other systems, when I start a project out in those MPP systems, you've got to start up the entire MPP system and load it with maybe small amounts of data as you start off with a POC. That is not the case with Snowflake. So there's some of the benefits there. There's a couple other questions that people were asking. Let me see if I can find.
Yeah, I thought there was an interesting question about sort of the use cases.
Let me see if I can find that one.
So a possible Snowflake use case for a small medium company that has several OLTP systems. I thought that was kind of an interesting question.
Right. Yeah. And that's kind of where I was going with you can start off slow, so it doesn't have to be large amounts of data, but you start off slow and you just have a small Snowflake bill. So it doesn't have to be large sets of data. But the nice part about it is if it ever did get large, you don't have to change anything. You can scale up different compute, warehouses, and you don't have to change the way you're doing things. And those other platforms, you have to spread the data across nodes. You have to do, create indexes and stuff like that. It becomes a little bit more management from that standpoint.
Yeah, I saw the one user commented we still need to use clustering instead of indexes when the data is huge, and that's kind of one of those things where it may be hard for DBAs, but you have to kind of get used to maybe letting go of the reins a little bit and trusting that Snowflake's going to handle that in the background or use the auto scaling features and things like that.
Right, and I've seen it to where I have not. There's one case, and I don't know why I didn't look back and try to figure out why it wasn't. But every time I scaled up, it cut the cost in half. So theoretically, it's actually the same cost, if not cheaper, to scale up. So let's just use as an example, I had a query that, let's say, ran for an hour, and I was running on an extra small. If I turned it to a small, so I scaled up, so now I'm being charged instead of $2 an hour, $4 an hour. Usually that cuts in half, and I've seen almost every case where that would cut in half. So now it's 30 minutes. So really, even though it's $4, so it's more per hour, I only used it for 30 minutes. So it's actually the same cost. And usually it scales down to at least 50%. And I've seen it, and it depends on the type of queries and things that you're doing where you can scale. I mean, we were doing joins on almost trillions of rows, joining a trillion row table with another table. It was running on a 4XL, which is huge, but it ran in, I think, 13 minutes. I can't imagine you putting that on a system where that would even run. And if you say, well, I don't even have close to that data scale, that's fine. You can still run with the same type of performance, and now you're running on extra small, and you just have extra small warehouses, and that fits your need for your entire enterprise.
Cost effective. I saw one other great one here is Snowflake's so fast, do we need to worry about our data scientists' terrible SQL?
I was going to pick that one too.
No offense to the data scientists out there, right? And really, on top of not only it being fast, it's this idea that you've isolated your data scientists into their own compute space so that their compute, if they tax it out completely, if they don't, it doesn't matter because all your reporting, assuming you've set up a reporting specific data warehouse or compute, is not impacted at all by what those data scientists are doing. So that's a major benefit of this idea that compute and storage is separate, and then compute is just fully separate from each other.
Right.
Yeah, that's a great question. I mean, there's always when you get performance, and then you sort of can enable bad habits, and we've seen that with things like Netezza and columnar databases and across the spectrum. So you still want to design things well. There was another question, and I want to be mindful of the time here as we're at the top of the hour, but about needing to create a presentation layer on top of that data for reporting. Do you have anything to say about that?
You don't have to. So Snowflake is like any other database. I could do that from a security standpoint if I wanted to create views on top of it to be able to then provide different security but to those views. But no, you don't necessarily need to put a presentation layer on top of it. It's not to say you couldn't with some kind of thing in between like a view, but you don't have to do that because you can connect directly. You, as you saw with the tools, you can connect directly with the Tableaus and the Power BIs directly to Snowflake.
And given you are hopefully designing it with analytics use cases in mind, it'll have some of that dimensionality and things, so you won't have to do as much modeling on top of it as you would, say, a transactional third normal form database.
I'm gonna wedge one more in here before we kind of wrap up, I think. This idea of security and users and accounts and things like that. Can you just touch a little bit on per user licensing costs, Reeves?
There's not a cost on, there's no per user licensing cost. You are being charged on a compute and storage. It's actually very easy. There's actually three. There's moving data outside the environment. You can pay for that, but that's usually a minimal cost. The two costs are storage and compute, and it doesn't matter how many users you have. If they all use the same data warehouse, then you're fine. But if you have to create different data warehouses for different groups of users, then you can do that also. But there's no cost on a user basis.
Yeah, and security is such a deep topic. I mean, there'd be so much to go into there, but you could have individual users, you could have users at the, tool or purpose type level, different ways to approach that. And we'd be happy to talk on it on a call in depth.
Right.
And you could do particular needs.
Yeah, and you can do federated access. So you can set up your ADs, you can set up Okta and those kind of providers to be able to have your users log into Snowflake without having to have a login. They can just authenticate to it from that standpoint. So, yeah.
Excellent.
Great. Well, that was fabulous. So any of you, the questions that were submitted, we will respond to those in a written response document that we'll post to Senturus.com along with the recording and today's deck. And again, as you can see, this is fascinating technology. So any of you out there who are, looking to retire that old DB2 database sitting on an AS400 in the corner of your basement somewhere, you're looking to modernize your database strategies, get better performance, enable self-service, move from on-prem to cloud, give us a shout. So if you want to move to the last slide, Bob, first of all, I want to thank Bob and Reeves for a great presentation, some great content today. And of course, thank all of you for joining us and taking an hour out of your day for this edition of the Knowledge Series. So again, if we can help you with that or any other analytics types of challenges or projects you might have or training, please feel free to check us out at the website. If you still use a phone, 888-601-6010 or info@senturus.com. Thanks for joining us today, and we look forward to seeing you on one of our upcoming Knowledge Series events. Thanks a lot, and have a great rest of your day.
Thanks. Take care.